Hello, in the last video we discussed what is binary search, why it is used and its time complexity. Now let's discuss the next parts. So a pointer points to a valid memory location. So an iterator is a type of pointer which points to the element in the container. So now let's discuss two primary important functions in STL. So the first one is lower bound and the second one is upper bound. And these are related to binary search. So the first one, lower bound of x returns the iterator to the first element in the container which is greater than or equal to x. So it returns a pointer which is pointing to the first element which is greater than or equal to x. Similarly, the upper bound of x returns iterator to the first element which is greater than x. So these will work properly only if the elements are stored in non-decreasing order. So they should be in increasing order. So these will work in a sorted vector or in a map or in a set or a multiset because these are already increasing by default, and if it is sorted they are in non-decreasing order. So we can use lower and upper bounds in this. And now let's discuss some points related to both. So if the array is of n elements and this is the 0th index and this is the last index, v dot begin is the iterator that is pointing to the 0th element. So v dot begin points to the 0th element. And similarly, if the last element is n minus 1, the pointer pointing to the next one is v dot end. So if this is v dot begin and v dot end, the next index, which is first index, is v dot begin plus 1. So this is v dot begin plus v dot begin plus 0. This is v dot begin plus 1. As this is v dot end, the last element will be v dot end minus 1. So 0th index is v dot begin and n minus the last element, which is n minus third index, v dot n minus 1, is v dot begin plus n minus 1 because the first index is v dot begin plus 1, and similarly the last element will be v dot begin plus n minus 1 because this is the index of last element. And this is, and if we equate both, we will get that v dot end is equal to v dot begin plus n. So now lower bound of v dot begin plus 6 and v dot begin plus 5 and z. This implies that we are trying to find the search space which is x and y minus 1. So here the x and the last pointer y is not included. So it will be x and y minus 1. And we are trying to return the pointer which is greater than or equal to z in the range x and y minus 1. So we want to search in the whole array initially. So the range will be 0 and minus 1. So if we equate this both, we get that x is equal to 0 and y is equal to n. So to search in the whole array, the range will be v dot begin and v dot begin plus n. So from this we can see that v dot begin plus n is equal to v dot end. So for the search space 0 and n minus 1, the lower bound of v dot begin and v dot end will work. So now coming to next one, let's take an example. So this is sorted vector and we want to find lower bound of 5. So lower bound of 5 returns the pointer to first element which is greater than 5, greater than or equal to 5. So from this we can see that this index is the first one which is greater than or equal to 5. So v of index is 8. And similarly, if you are trying to find upper bound of 3, this is the first one which is greater than 3. So it will return 4. So from this, for example, we are trying to find the number of times 3 occurred. So to find this, we want the first occurrence of 3 and last occurrence of 3 so that we can return difference plus 1. So how can we find the first occurrence? As we just discussed, we can use lower bound of 3 to get the first index which is greater than or equal to 3. And similarly, we want the last occurrence, but there is no direct one to find the last one. So what if we can do the lower bound of 3 plus 1? So if we try to return lower bound of 3 plus 1, it will point to the next element which is 3. So the before element will be 3. So upper bound of 3 will be the pointer to the next one. So now if we try to find whether v of index 3 is equal to 3, where we are doing this, for example, if the array is 4, 4 and 5, and now we are trying to use lower bound of 3. So lower bound of 3 will be pointing to this, but we are not sure whether this is 3 or not. We are sure that it is greater than or equal to 3, but we are not sure whether it is equal to 3 or not. So to find whether there are any occurrences of 3, it is correct to check whether it is 3 or not. So if it is 3, we are sure that index 3 is 3 and all indices still index 4 minus 1 are 3. So the difference plus 1 will be the count of 3. And if this is not 3, this means that there is no at least an occurrence of 3. So the answer is 0. And now coming to next one. Two few observations are, if iterator pointed by the lower bound of x is not equal to x, it means that x is not present in V, as similar to this. And now if an iterator pointed by upper bound of x is v dot n, this means that no element is greater than x, because if there is an element at index I which is greater than x, the pointer will be pointed to that index. But if it is v dot n, which means that there are no elements in the array satisfying the given condition, and hence it is pointing to the next location of last element. And similarly, we can use upper bound in maps and sets. The syntax is almost similar. So mp dot lower bound of x and mp dot upper bound. Similarly, h dot lower bound and h dot upper bound. So if we find if this is equal to mp dot n, it means that all elements are less than x, so that there is no pointer which is pointing to element which is greater than or equal to x. And similarly, if upper bound is not equal to n, it means that we found an index where this is greater than x. So we are trying to print star it dot first and star it dot second, and similarly for a set. And now let's try to discuss another one. So we discussed that we can use binary search on sorted vector. So we can use sorted vector of pair of int and int. So 2, 3, 2, 4, all these are sorted based on the first one. If first one are same, y are increasing, and if the first one is not same, then the one which has x highest x is greater in the right side. So now if we are trying to use lower bound of a comma b in the vector, the priority is second one. So lower bound of a comma b will try to find the first one with first value a and the second value greater than or equal to b. The lower bound in the single array is trying to find greater than or equal to b. But now as this is a pair, it will try to prioritize the second one, because it will try to find the first one with the first value a and second one greater than or equal to b. And if there is no such value, then it will try to find the first one which is greater than or equal to a, and then the second one is useless. So lower bound will try to find the first one with a and greater than or equal to b, and if there is no such pair, it will try to return greater than or equal to a, and independent of this, it will just try to find the first one with first value greater than or equal to a. And similarly, upper bound of a comma b will try to find the first one with a comma greater than b. So if there is no such one, it will try to find the first one with greater than a, and it is not useful, because this is independent of the second one if we are assuming that it is greater than a. Hope you understand this. Now let's take some examples. So the pair is 2, 2, and we are trying to find lower bound. So we discussed that it will try to find the first one with 2 and greater than or equal to 2. So the first one is the first index itself. So it will point to that, and the output will be 2, 3. And now we are trying to find upper bound of 3, 6. So we discussed that it will try to point to the first element with 3 and greater than 6. But there is no pair with the first element as 3. So it will try the first one which is greater than 3, 4. So similarly printing this will give 4 and 5. And now similarly, if we want to find the number of pairs with the first value as 4. So as similarly in the 1D array, we can try to find the first occurrence of pair with first value as 4, and similarly last occurrence of pair with first value of 4, right? So how can we do this? We discussed that lower bound of 4, x will try to point to the first one with 4, greater than or equal to x. But now our main goal is to find the first one with greater than or equal to 4, that with 4 and greater than or equal to x. So our main goal is that any 4, the second value should satisfy this. So when it will satisfy, so if the second one is int min, we are sure that any value in the second one is greater than int min. So surely it will point to the first element with first value 4. As we are using int min, we are sure that any value in the second index is surely greater than or equal to int min. So it will point to the first one. So if we are trying to use lower bound with int min, we will get the first occurrence of 4 and 5. Similarly, lower bound of 4 and int max. This means that it will try to find the first one with 4 and greater than or equal to int max. Int max is infinity. So we are sure that there will be no element with greater than or equal to infinity. So now it will try to find with 5 and other one. So if we try to use with 4 and int max, it will return to the next one, which is 6 and 1. So similarly, we can decrement the index and we can return the count. So if we are trying to use lower bound with int min, we will get the first one. And if we are trying to use 4 and int max, it will try to return the 1 plus last occurrence of 4. Hope you understand this. If you have any doubts, comment below. See you in the next video.